Hello everyone. Today I am going to discuss about how to calculate the length of a list in Prolog. In the Prolog terminal, we are supposed to give a query. Now here, the sample query has been given as question mark hyphen is the place where we need to give the query, and the query is len within bracket. There are two parameters. The first parameter is used for the list that I am going to provide as an input to the predicate, and on the second parameter of the predicate len is r, where the output will be calculated. And as we can see in the sample output, the length of the list that is given inside is 1 2 3 4 5, and the length is r equals to 5. Now let us check how Prolog calculate the length of a list. As we know, Prolog performs the entire calculation by the help of recursion. So here in the left hand side, representing the program logic, where in the first line of the program logic, it written as len within bracket blank list comma 0. This indicates the base condition of the program logic to calculate the length of list. And on the second part, which is the alternate logic, it written as len within bracket the list has been split into head and tail. After the list comma r, which is the output parameter, and then the rule defines as colon hyphen, then len accepting the tail, discarding the head, and then the second parameter is the new variable which is calculating or receiving a new output from the newly identified list, that is the t, because earlier the original list contains head and tail. Now we have discarded the head and we accepted the tail only. Thus with the new list, that is the list containing the tail part, we will compute a new output. This is a recursive call. So recursive call actually giving an input of newly modified list, that is with the tail only, and then with the newly modified list, the new output will be come into new output variable, that is r1. Now once this recursion is done, then rest of the part, that is r is r1 plus 1, will be computed. So this is the entire program logic. Let us see how the program logic calculates the entire length of the list, that is 1 2 3 4 5. Now when the Prolog receives the query, that is the list 1 2 3 4 5 inside the predicate len, it first checks the stopping condition, because stopping condition is the first program logic written for the program length. Now here it checks whether my given list is empty or not. No, here in the first line the given list is not empty, it contains the element 1 2 3 4 5. So the first part is not executed, it is false. It going to the second part. In the second part, here it checks whether the program can be carry forward as per the logic or not. So here it receives the original input and it splits the original input into two parts, that is one as a head and the rest of the part is another list which is called as tail. Now this tail is stored in a variable called t, and the head part, that is 1, it is stored in another variable called h. Now we are not interested with the head part, so on moving with the rule, we call the len predicate recursively, and in this case the first parameter will be having input as 2 3 4 5, that is we have removed the head part of the original list. So now the list modified as 2 3 4 5, and this new list will be calculated with new output variable, that is r1. And since this is a recursive call, so the first priority is whenever there is a function call, the program always transfer that call to that particular function. So in this case, whenever this len has been called, it will automatically again go back to the starting of the functions, where again the len will be calculated as if it starts from the beginning. And what about the rest of the part? Now, as per the recursion rule, the rest of the part will be stored inside the stack. Now, after storing the rest of the part, the program again starts resuming it with as if a new function call has been started. Now, again the new function call has been started with the new list 2 3 4 5, where it checks whether the new list is empty or not, because it is again checking with the base condition, because this is the rule of the recursion, to check the base condition each and every time it enters the program. Now once it is false, is go to the next line where it split the list into two parts. Now 2 has been splitted, 3, 4, 5 as a tail has been splitted. Now this tail has been again recursively passed into the predicate. So 3, 4, 5 has been passed into the predicate with a new variable r1, and again rest of the portion, that is r is r1 plus 1, for this recursive call will be pushed into the stack. Once it is done, again with the new list, that is 3, 4, 5, since at this stage the program len has been executed again, so recursively it will again go back to the start of the program, that is the base condition, with new list 3, 4, 5. Now again it will check whether base condition is empty or not. It is false, so it moves again it split into head and tail. Again the tail part has been recursively called. Again 4, 5, it is not empty. Again it splitted into 4 as a head, and only 5 is only the current tail element. So again the 5 will be passed into the len predicate as a list. Rest of the element will be again moved into the stack. Again it will be checked with the base condition. Again it will be splitted into head and tail. Now we can see that the tail is empty. So the empty list, now the recursive call will be happened with the empty list, and the output parameter will be same as r1. Every time the recursion function is being called, the output parameter, the name is same, but every time where the variable name may be same, but for a new call there will be a new memory location, new memory address for each r1. So the different type of r1 has been called. Each and every time there has been a different memory space has been allocated, because this is what the recursion function is all about. Now rest of the portion has been pushed into the stack again as usual. Now once it is done, now this portion length blank list comma r1 will be passed again and will be called from the beginning. So beginning means base condition. Now once the base condition is hit, here in this case it will become true. So it will become true means now my r1, whoever have called this empty list, who called this empty list? This particular function called this empty list. So len 5 empty comma r, this particular function called another function of same name len, providing into the input parameter as a empty list. So this particular function called this empty list function recursively. Okay, thus whenever it hits the empty list condition, base condition becomes true, it reports the value 0 back to the caller function. So here the caller function is this one. So here the r1 becomes 0. Here r1 becomes 0. Now this 0 has been passed into r1, and thus once the r1 becomes 0, now the last recursive stack element was popped out and its value is been calculated. So now r1 value we have already received 0 from the base condition. Now this 0 plus 1 will be calculated and will be stored in r. So this r value is for whom? This r value is originally for this particular function, where in the input side it only had element 5, and for element 5 the r is 1. See, when the list was empty at that time, the length was 0. As we know, the second parameter r is basically calculating the length or storing the length. So for base condition where the list is empty, it is storing 0. Now when the list is storing only one element 5, now at this stage 5, the r becomes 1, and the r is becoming 1 because of it is getting calculated as r is 0 plus 1, where the 0 is coming from the empty list, and this empty list is being called from the function or the predicate that contains only a single element 5. Thus, because of this single element, after calculating the empty list, R is calculating 0 plus 1. So basically it is adding plus 1 with the previous result. With the previous result, it is adding plus 1 so that the value of R could be updated for whom? For the function which is currently in execution. That is, the current execution function contains only a single element 5 and the tail part is empty. So for this case, R is equals to 1. Now the program is not complete yet because the original length of the original content of the list is 1, 2, 3, 4, 5. Currently, here we have only one element in the list, that is 5. So where about the rest of the element? So since there are a lot of elements already present in the stack, as you can see over here, so the system goes on. So it will continue to that caller who have called this function recursively with only one element. So let us go to the previous one. So let us pop one from the stack, and here we could see that len 5 r1 was called by len 4 5 r. So this one called this function. Now here from the previous stage, r1 has been calculated. R1 for what? R1 for 5 has been calculated. So using this r1, so R is being calculated. These are for whom? These R is for this particular function, or that is predicate, where it contains two elements 4, 5. 4 is the head, 5 is the tail. But it doesn't matter. When it is watch over as a parameter, it will be as a one element, that is, it will be as a one list, that is a list containing 4, 5. Now, by using the previous value, that is using the result of this particular function, R1 is 1, where 1 is again incremented and R is being calculated, and this R is for this particular function where list contain 4, 5. Now someone has called 4, 5. Let us go back. Now again the last element has been popped out. 4, 5 has been called by 3, 4, 5. Now earlier R value was 2. So here this R1 is basically the previous R. Now because we know that for a function call, variable never get passed, rather the value of the variable always passed. So do not confuse with the name of the variables. So earlier it was R, right now it was R1. So what is happening? It is happening as simple as that, the value is being passed. Earlier the variable that is storing the value 2 was R. Right now this 2 has been passed recursively to the caller function, where the caller function was this one, and it has been received as R1 at this stage. So now R1 is 2. So the current R value for this function is R1 plus 2 plus 1. Again moves on. Same thing happening. Again moves on. Same thing happening. And finally we are getting R is 4 plus 1, that is 5 as the output. And the stack is empty. Once the stack is empty, there are no elements left to pop out, and the function go back to the original state. By backtracking, it go back to the original state, and the program halts, giving the output as R equals to 5. This is all about how the length of a list is being calculated. Now, your task is to calculate the sum of all the elements in the list. There is a little change with this logic, with this existing logic, to calculate the sum of all the elements present inside the list. Sum of all the elements means 1 plus 2 plus 3 plus 4 plus 5. What will happen will be stored in R, and this is your homework. Comment me.